So what is the probability that at least one roll of 10 rolls is a 6? All right, so the probability at least 1, 6 and 10 rolls is going to be 1 minus 1 minus the probability of this guy. And this will be in parentheses to the 10th power. 1 minus 1 minus, all right? So this is equal to 1 minus, probably a 6 is 1/6. This is 1 minus 5/6 to the 10th. And if you were going to put that in your calculator, I would just type 1 minus and then put the parentheses, 5 divided by 6. So here's the calculator. 1 minus, open parentheses, 5 divided by 6, close parentheses, and then I don't have to type a caret or whatever. Y to the x or whatever, 10. And if you put that in there, you get 0.838. So most of the time, even though a 6 is unusual, it's not really unusual. It occurs 1 in 6 times, but if I roll 10 times, I'm likely 0.838. It's very common for me to get at least 1/6 out of 10 rolls. Would it be unusual to get no 6s? Now this is an interesting question, given none are 6s. All right, so here is something we were just talking about. We had a complement for. Well, this is 1 minus the probability of the complement of that guy. And so what's the complement of none of them are 6s? The complement of none are 6s is that at least one is a 6. And that's this. We just calculated that. So this is just 1 minus 0.838, which is 0.162. Is that unusual? No. Well, it's very common for us to have at least 1/6, 84% of the time. Getting no 6s is going to happen 16% of the time. So that's really not a big deal either. All right, so these both can happen. 16 out of 100 times that we roll a die 10 times, we're going to get no 6s. 84 out of 100 times, we'll get at least 1/6. So those are both typical values. We expect those kind of things. All right, so it says, what would be the probability we get a 6 on the first and second roll, then the rest are not 6s? All right, so we got probability of 2 6s, and then the rest, and we're rolling 10 times, so then 6 not 6s. All right, so this is going to be, since these are independent, this is going to be the probability of 2 6s times the probability of 6 not 6s. Probability of 2 6s is going to be 1/6 squared. The multiplication rule for independent events. Not 6s, that occurs 5/6 of the time. Not 6. There's 10 of them, so this is 8. Sorry. Okay. The 8th power. Yeah, notice those should have added up to 10. So, all right, so let's do an example. What is the probability that at least one roll of the 10 rolls is a 6? All right, so we're going to roll 10 times. So the probability of at least 1/6 equals, and with our at least one rule, this is going to be 1 minus parentheses 1 minus. And then we're going to want the probability of this guy. And this will be raised to however many trials are. All right, so this is 1 minus 5/6 to the 10th. And this is equal to 1 minus . Okay, so that's 8s, not 6s, not 6. All right, so what's the probability of 2 6s and 8 not 6s? Well, since these are independent, then these are going to be equal to the probability of 2 6s times the probability of 8 not 6s. So probability of a 6 is 1/6. I got 2 of them, so that's going to be 1/6 squared by the multiplication rule times the probability 8 not 6s. The probability of not 6 is 5/6. Oops. So that's going to be 5/6 to the 8th power. And this happens to equal point. What's going on? There we go. 0.0064. All right, so is that unusual? Yes. This is not going to happen very often.